Hello everyone and welcome to Similar Triangles. So please make sure you have page 41 in your packet in front of you. This is very important. It talks about three different ways to prove that triangles are similar. So the first one was angle, which we've done in class before, and it kind of looks like this. The angles are congruent. So please fill that in the box. The second one is number 2, and this is side, angle, side for similarity. So what's going on here is that the sides are in proportion, and the angle between the two sides, notice the A is right smack in the middle between the two sides, is congruent. So that's another way to prove similar triangles. And then the last one is if all three sides are in proportion, then we are pretty much good to go and we have similar triangles as well. Okay, so please make sure you copy that. After this, we're going to turn to page 44. So now we're on page 44, and it talks about this example. It says in the diagram below the triangles are similar, and it says that angle C is 120 degrees, so go ahead and fill that in. Angle F is 15 degrees, and although we're supposed to draw it inside the triangle, it's pretty small, so we'll just put it there. I'm going to label my sides in red, so AB is 20, and it says that EF is 10, and it also tells me that AC is 8. So the first thing we're trying to do is we're trying to figure out what angle E is, so the measure of angle E. Now, if we know that this is 15 here, this number right here, we also know that angle B is going to be 15, and we also know that if this is 120, then angle G is going to be 120. So in order to figure out how much angle E would be, we're going to take 120 plus 15 to get 135, and then we're going to do 180 minus 135 to get 45 degrees. So all the angles in similar triangles are going to be equal, so we also know in here that angle A is also 45 degrees. And the triangles the angles in a triangle add up to 180. Okay, let's take a look at the next part. Then it says find the length of EG. So I'll do that in red. You have to remember we're going to call this X in this case. And we happen to know that the corresponding sides are in proportion. So if I was to look at this 8, it lines up with the X. And if I looked at this 20, it lines up with the 10. So in order to do that, I'm going to do 20 over 10 equals 8 over X. I can certainly solve for x, or I could just notice that if I reduce the fraction, that x is going to be equal to 4. Your other option is to do the product of the means is equal to the product of the extremes. Notice 20 times x is equal to 8 times 10, and then x is equal to 4. So that's another way to do that as well. Now we're going to go to page 45, please, the next page. So this one is a bit tricky. We are talking about coming up with a 2-column proof of why the products of these segments are equal. Now keep in mind that if we are going to prove products of segments are equal, we definitely want to prove that two triangles are similar. And one of the hard parts is figuring out which triangles that's going to be. So I would write CE over AE equals EF over ED. Now think about that for a second. If we were to do the cross products, I would have CE times ED. In essence, that's like cross multiplying or doing the product of the means equals the product of the extremes. And then I could also do AE times EF. So I know that those are equal. The next thing to do is try and figure out which two triangles you want to prove are congruent, and we're going to prove triangle CEF going across this way. CEF is in fact similar to triangle AED going across this way. So I'll write that over here. Triangle CEF is similar to triangle AED. Now, in order to do that, we're going to use the fact that we have altitudes. So altitudes make right angles. I'm going to put 2 right angles right there. I'll call them 1 and 2. And I also could realize that I definitely have vertical angles in here. I'll call them 3 and 4. Now, this gets a little rough, so I'm going to go to the next page to show you the proof. This is the proof written out. So notice I start with the fact that we definitely have altitudes. So C, D, and AF are altitudes of triangle ABC given. 1 and 2 are right angles. Altitudes are perpendicular to the base and make congruent right angles. Then it's congruent. All right angles are congruent. 3 is congruent to 4 vertical angles. The triangles are similar based on angle. The corresponding sides are in proportion, and then the product of the means equals the product of the extremes. Please make sure you take a moment and copy that. You can pause the video if you have to, but I'm going to move ahead. Now on this one, example 2 on page 45, it asks whether or not the triangles are similar. Are they similar? So what I have to do is look at the relationship between the sides, and I also have to look at the angle in between them. So if I was to look at the relationship, it seems as though AB, side AB, is going to match up with DE. We don't know any information about those. We also know that side BC is supposed to match up with EC. Notice the order of the letters. So BC over EC should, in fact, be equal to AC over DC. Now we're going to put some numbers in and see what happens. So BC is 12, EC is 3, equals, and I'm going to put a question mark on top of that, AC is equal to 20, and CD or DC is equal to 5. To check to see if these are in fact in proportion, we do the product of the means equals the product of the extremes. So I could multiply these two and see if they're equal, and oh look, they are equal. So we know that they are in proportion. By the way, a little side note over here, the scale factor would probably be 1/4, because we took this big triangle here, AEC, and we dilated it by a scale factor of 1/4, and it became this little triangle. Now, clearly we did some reflections as well, but just for conversation's sake, the triangle got smaller. So to answer the question, we're going to write this. Yes, because there are two sides that are in proportion, and the included angles are equal. So please make sure you write that down. Now we're going on to the last page, so it's page 46. Again, we're trying to figure out if corresponding sides are in proportion. One of the things that I could look at is triangle A. I'm going to look at triangle B, and I'm also going to look at triangle C. It would be in my best interest to put the sides in order from least to greatest. So I have 3, 4, 6. In B, I have 8, 12, and 16. And in C, I have 4, 6, and 8. Now I look for a relationship between any two pairs of triangles, and it appears as though there is no direct proportional relationship between a 3, 4, 6 and an 8, 12, 16, so that doesn't seem like it's going to happen. I could also check a 3, 4, 6 with a 4, 6, 8, and clearly those are not similar because the corresponding sides are in proportion. But the last thing to check, which is probably the most important and the most accurate, is if I was to look at this 8, 12, 16 and compare it with the 4, 6, 8, I could see that all I have to do is multiply these sides by a half, and it would give me those sides. So I could definitely say that triangle B is similar to triangle C because the corresponding sides are in proportion. Thanks, and I'll see you later. Bye.